What is an exponent? An exponent is a base to a power. So the base would be x and the power would be y. So if the base here is x and the power is 4, then x to the fourth equals x times x times x times x. Laws of exponents. So the first one would be x to the 1 equals x. Then the next one is x to the 0 equals 1. And this is because if you have 5 to the third equals 125, 5 to the second equals 25, 5 to the first equals 5, then 5 to 0 is going to equal 1, and this is because each time you decrease by 1 power, you divide by 5, the base. So 5 to the second is 25, 5 to the first is 5, that divided by 5, so 5 divided by 5, is 1, which is why 5 to the 0 equals 1. The next law is x to the a times x to the b equals x to the a plus b. Now the two exponents are added because if you take this example, 2 to the second times 2 to the third, that example is basically saying that 2 times 2 times 2 times 2 times 2, which is equivalent to 2 to the fifth, which is also equivalent to 2 to the second times 2 to the third, it is shown that the 2 and the 3 are added, which equals 5. This next law is that x to the a over x to the b equals x to the a minus b. Now the two exponents are subtracted because in this example 2 to the third over 2 to the second, which is equivalent to 8 over 4, which equals 2, which also equals 2 to the 1. So 2 to the 1 is equivalent to 2 to the third minus 2, as 3 minus 2 equals 1. This next law is x to the a in parentheses and then 2 to the power of b, which equals x to the a times b. Now this is because if you take the example 2 to the third and then 2 to the second, that is equivalent to 2 to the third times 2 to the third, which equals 64, which also equals 2 to the sixth, which also equals 2 to the third times 2. This next law is saying that x times y and then all of that to the power of a equals x to the a times y to the a. Now the a is distributed because if you take this next example to prove that, which is 4 times 5, all of that squared, which equals 4 times 5 times 4 times 5, which equals 4 times 4 times 5 times 5, which also equals 4 squared times 5 squared, ultimately proving that this law works. This next law is that x over y and then all of that to the power of a equals x to the a over y to the a. Now the a is distributed because, in this example, as shown, 3 over 4, all of that squared, equals 3 over 4 times 3 over 4, which equals 3 times 3 over 4 times 4, which is also equivalent to 3 squared over 4 squared. This next law is x to the negative a equals 1 over x to the a. Now if you take the example 2 to the negative third, which equals 2 to the 0 minus 3, which we learned from a previous law that when they are subtracted, they become divided, so 2 to the 0 over 2 to the third, which is equivalent to 1 over 8, which also equals 2 to the negative third. The next law is x to the 1 over a equals a root x. This can be explained by this example that 3 to the 1/2 equals the square root of 3. Basically that it is just the inverse. This next law is x to the m over n equals n root x to the m. This can be shown through the example 2 to the 3 over 4 equals 4 root 2 to the third, as we learn that the bottom number becomes that number of a root, so 4th root 2 and then 2 to the third. Here are some easy practice problems for you to try. Pause the video to solve. Here are the answers to the practice problems. Please pause the video to check. Here are the harder questions. Please pause the video to solve. Here are the answers. Please pause the video to check your answers. The next section is logs. So here, for a problem where you can't solve the equation using the exponent rules, you need to go to a log. So to go from exponent to log, the equation looks like this. X to the y equals b, and in terms of log, it would be log base x b equals y. There is a common log, so when you do not see a base like log b, the base would be log base 10b. This is what the log is in your calculator. So when you put in log, you automatically get that common log with the base of 10. Here's the first law of logs. The first one is log base a 1 equals 0. This can be demonstrated as we know that a to the 0 power equals 1, and if you were to flip it back to exponential, vice versa, you get that answer. This next law of logs is that log base a equals 1, which basically says that if you flip it back to exponential, a to the 1 equals a, which we learned from the rules of exponential logs. This next law is that log base a m plus log base a n equals log base a m times n. Now this can be shown through log 3 plus log 4, which equals 1.08, while log 12 also equals 1.08. Now 3 times 4 is 12, proving this law. This next law of logs is that log base a m minus log base a n equals log base a m over n. Now if you take the example, log 6 minus log 2 equals 0.477, while log 3 also equals 0.477, you can notice that 6 divided by 2 equals 3, proving this law. The next law is that n log base b m equals log base b m to the n. So basically the coefficient becomes the exponent. So this can be shown through 3 log 2 equals 0.9, while log 8, which is 2 to the third, also equals 0.9, once again proving this law. Next is a log theorem called the change of base theorem. Now this basically says that log base a x equals log base b x over log base b a. Basically taking the number, so the x, and giving that the same base as what used to be the base a, and putting them over each other. And this can be shown through a number example that log base 2, 3 equals log 3, so the common log, over log 2. Here are some practice problems. Please pause the video and solve them. Here are the answers to the practice problems. Please pause the video and check your answers. Here are some harder problems. Please pause the video and solve. Here are the answers to the harder problems. Please pause the video and check your answers. Natural log is ln, which equals log e, as ln is the inverse of log e, and e is Euler's number, which e equals 2.718281828, and it goes on forever like pi. Now ln uses e and can be solved for back and forth just like log and exponential form. Here's how to go back and forth between the two, as e to the x equals y, so ln y equals x. This can be used when solving. Here are some examples to try. Please pause and solve. Here are the answers. Please pause and check your answers. This is an application of the natural log in terms of interest compounded. So the equation is a equals p times 1 plus r over n to the power of n times t, where p is the principal amount, r is the interest rate, n is the number of times the interest is compounded per year, month, it depends on the question, and t is the number of years. Another application of natural log equation is interest compounded continuously, and this is a equals your principal amount, p, and then e to the rt, rate and time. The last application of natural log is the half-life equation, which is a, final amount, equals a1, the initial amount, times 1/2, this is the split factor, the half-life, and then to the power of t time over h, the half-life. Here's an equation for compound interest. Please pause to solve. Here is the answer. Please pause to check your answer. Here is a question for compounded continuously. Please pause to solve. Please pause to check your answer. Here is a half-life question. Please pause to solve. Here is the answer. Please pause to check your answer.